Find the length of the pipe. Use the midline of the pipe to determine the length of the vent section. Round to the nearest hundredth of an inch, round to the hundredth of an inch. Alright, so here we have a pipe. We have a 6-inch section here, we have an 8-inch section here, and we want the inner diameter, it looks like this is the inside diameter of this vent pipe, to be 2 inches. And the pipe itself is 1 inch thick. So let's kind of zoom in on where this pipe is bent. So I said the inside diameter, because when we have thickness to this pipe, the distance from the center of the circle, if this is a circular section right here, the distance from the center of the circle to the inside of the pipe, this is 2 inches based on this drawing. If I was to go from the center of the circle to the outside of the pipe, over here, this would be 3 inches, because this pipe is 1 inch thick. But in this problem, and in general in this class, when we're talking about trying to find the length of these things, we're going to be using the midline of the pipe. So we're going to be kind of splitting the difference. We're not going to call it the inside or the outside diameter. We're going to use the midline, which is, if this is a 1 inch pipe, then this would be a 1/2 inch thicker. This right here would be 1/2 inch. And so this to the midline would end up being 2.5 inches, 2.5 inches to the midline of this pipe. That's the radius we're going to be using to figure out the length of this pipe. Now the reason for this is because if you think about starting with a straight pipe, when you bend it, as you bend this pipe, then the outside of the pipe here is going through a longer arc than the inside of the pipe. And it turns out when you bend a pipe, you would get some stretching here. The copper I'm thinking of a copper pipe here. The copper on the outside would stretch. It would become a little bit thinner because it's going a little bit longer distance. But that's not all that's happened. You also get a little bit of compression on the inside of the pipe, on the inside of the curve. So it turns out this distance right here, if this started out as being, let's say, 10 inches long, then it turns out when you stretch this, this distance from here to here would be just over 10 inches, and this distance from here to here would be just under 10 inches. Because of the stretching that happened here and the compression that happened here, these are not going to be the same. You can see they were the same length when the pipe was straight, but when you bend it, this distance is going to be greater than that distance. And so what we're going to do, it's probably not 100% accurate, but it's going to be more accurate than using either the outer or the inner. At least this is the way we're doing it. We're going to use the midline as our measurement, like I said. So we would call this a 2.5 inch diameter, and that's the distance we're going to use of the pipe. So we're kind of assuming that the stretching and the compression would take place in roughly equal amounts. You know, the same amount that we gain from the stretching would be the same amount lost to the, well, whatever, the same amount lost to the compression. All right, so in this problem, we have a 6-inch piece of pipe here, plus this curved part, plus another 8 inches. So you can see the total length of this pipe is just going to be 14 plus the length of the curve. So we just need to figure out what the length of that curve is. So the length of the curve, if this is a circular section, this would be, well, imagine a full circle here. This would be a quarter of that circle. And the total distance around the circle we call the circumference. So this is actually going to be a quarter of the circumference. So 1/4 of the total circumference of that circle. This is why I needed to know the radius, because you use the radius to figure out what the circumference is. So we got 14 plus a quarter, since we're doing a quarter of the circle, and the circumference is 2 times pi times r. And the r we're using is this 2.5 inches. I don't like having that line there. 2.5, that's what this r is going to be. So what I'm going to type into my calculator here is 14 plus 2 pi times the radius of my, nope, I forgot the quarter. 1/4 times 2 pi times the radius of curvature here, the radius of the center of the pipe, was 2.5 inches. So I'll just type that in, and we're going to round this to the 100th of an inch, which gets me right here, where that 2 is, because it goes tenths, hundredths place. The next digit is a 6, so I'll round it up to 17.93 inches. All right, find the total length of ornamental iron that is 1/2 inch thick, needed to bend this shape, round to the nearest 100th of an inch. So again, we have some circular sections and some straight sections. In order to figure out the total length of this, we're going to be using the midline of the pipe. Since this is a total of 1/2 inch thick, if we were to go half of that, it would be 1/4 inch. So that means each of these distances, I'll have to be I'll add on 1/4 inch to the radius, and I'm using the radius because that's what all my formulas are using. So this one right here, to the center of the pipe, actually let me redraw this because it's kind of a little hard to see what's going on there. So I'm going to go like this. It's hard to see what's going on in theirs, but it's better than mine, isn't it? Alright, so this distance right here, we're going to take this, the inner radius would be 4 inches, but we're going to go 1/4 the way, or we're going to go rather half the way through the pipe, which is 1/4 of an inch. So this radius right here for this section is going to be 4.25. It's 4 1/4 inches. Again, that's the half of the inner diameter. Half of 8 is 4, and then I'm going the halfway into the pipe. That's why I'm adding an extra 1/4 of an inch. So this upper section here, the total length of that would be half of the radius, or half of it's half of a full circle rather. So it's going to be half of the circumference. So 1/2 times 2 pi r. This is the upper. Plus we have the straight section, which is 6 inches. We don't need to do anything special for that. And then we have this lower part, and that looks like it's actually 3/4 of a circle. So I'll go 3/4 times the circumference, 2 pi r. I need to figure out what the radius is of this section. And similarly, on this one, half of the radius would be, from the center of the circle to the inside of this would be 3.5 inches. And then I need to go an extra 1/4 inch to get to the halfway part of this pipe, so this would be 3.75. That's what the radius would end up being there. So when I plug it into my radius formula here, it'll be 3.75. And that's what I'll type into my calculator. So 1/2, move this out of the way. 1/2 times 2 is actually just 1, so these actually just cancel each other out. I don't need to type both of those in. If dividing by 2 and then multiplying by 2 just cancel each other out. So I'll just go pi times 4.25. Pi times 4.25 plus 6 plus 0.75, that's my 3/4, times 2 times pi times 3.75, which gives me a total length of 37.02. I need to round this to the nearest 100th of an inch, and it looks like that 2 was at the 100th place. It's 4 or less, so yeah, 37.02 inches.